In this lesson video, we will be starting Unit 1B. And so for the first lesson, Unit 1B.1, we are talking specifically about angle relationships. We will be talking about different pairs of angles and the relationships created by those pairs. And so it's really important that we understand a lot of this beginning vocabulary. Okay? So as we start off, the first angle pair we want to talk about is the idea of what a vertical angle pair is, or vertical angles. Okay. Vertical angles, they're located across from or opposite of each other on two intersecting lines. They're always congruent, meaning they have the same measure, which means they're equal to each other. All right. So an example of vertical angles here might be like angle AFE here, and the vertical angle to AFE would have to be DFC. Here, AFE and DFC. They're formed by intersecting lines and they are opposite from each other. So they're exactly the same measure. We have really just that one pair of vertical angles here because those are the two full lines that we have that are intersecting. Okay, the next idea that we're going to look at is the idea of adjacent angles. Okay, adjacent, that word really just means next to each other or beside each other. So adjacent angles are angles that are beside each other or next to each other. They are not necessarily congruent. And what they're equal to, it just depends what they're equal to. There's not enough information there. So adjacent angles share a side. That's the other thing I want you to write down. They share a vertex and a side. So let's say I started with angle AFE. That angle is adjacent to actually two different angles because there's two sides that it could share with something else. But for our first example, we're going to say angle AFE is adjacent to angle BFE. You can see they share that side FE and they share the vertex F. Those are adjacent angles. Okay? Adjacent angles could also be angles BFC and DFC. Okay? But we also need to consider angles like this, angle EFD and angle CFD. Those are adjacent angles also. But in fact, they are more than just adjacent. These last two I just showed you here are actually an example of what we call a linear pair. So I'll write them again, angle EFD and angle CFD. Because they're adjacent angles that form a line or add up to 180 degrees. Okay, they add up to the straight line EC, or that straight angle EFC. All right, and they are always equal to 180 degrees when they are added together. Excuse me. So we have other pairs of angles here. I'm going to erase my diagram here and show you the other pairs of adjacent or linear pair angles we would have. Angle AFE and angle DFE. Okay, these two add up to 180. So they're a linear pair. That's another key idea we need to be able to identify today. So we're going to take a look at some other angle pairs. Now the idea of two angles that add up to 180 degrees gives us the idea of supplementary angles. And actually it could be three or more angles as well. Any angles that all together add to form a straight line would be considered supplementary. Two angles that add to 180 degrees, very similar to linear pair, but they don't always have to be connected, by the way, are supplementary angles. So we could do that with just two angles, like our linear pair, angle AFE and angle DFE. They add up to 180 like that. Or we could do them with three angles, maybe on this other side, like angle AFB, angle BFC, and angle CFD all add to 180 when added adding those three angles together. Remember our part plus part equals whole relationship. All right, so let's move right along into some other angle pairs. Now, we talked about supplementary angles just a second ago, and those are angles that add up to 180, but we also will look at angles that add up to 90, okay? Complementary angles add up to 90. The word complementary here means that two angles complement each other or add up to 90 degrees. So in this case, I've got my right angle here at F, and you can see that that is this angle BFC. So these two angles add up to 90. And so my complementary angles would be angle CFD and angle BFD. And so there's some key angle pairs we need to know about in this unit. And so as we move along, we can also talk about classifying angles, and you've probably done these before. To classify angles, we're referring to their measures, okay? Classifying angles depends on the measures of those angles. And so if we consider an angle to be an acute angle has a measure less than 90 degrees. Okay, something less than a right angle. There's the other one. I'll just skip over there and talk about it. If the measure equals 90 degrees, it is a right angle, and we have to put our box to show that it is a right angle. So that leaves two other kinds of angles, an obtuse angle and a straight angle. The obtuse angle is when our measure is greater than 90 degrees. And remember your symbols for less than and greater than. So I'm beyond a right angle. So I'm going to draw it bigger than 90 degrees. A straight angle is when our measure equals 180 degrees exactly. Straight angle is also a straight line. All right. So as we move forward, we are going to work on some problems where we're supposed to find an unknown angle measure. And so for these problems, these steps here are very important. You'll be given some information, and the first thing you need to do is draw the picture of the given information, then determine the relationship between those given angles. So one of these angle relationships we've just talked about, we're going to have to use that. And so I'm going to actually have you write that every time we set up a problem. You're going to do step 2, and you're going to write the angle relationship. Okay, in step 3, we're going to refer to the equal to part of our notes before, meaning what are we equaling in this process? What kind of equation are we writing? Are they equal to each other? Are they equal to 90? Or are they equal to 180? Those are really the only options we have for angle measure problems. And then lastly, we'll solve for x. We're going to plug back in if we need to. Just make sure you read the question. So number 1, we are given that angle A is 38 degrees. Find the supplementary angle and classify it as acute, obtuse, or right. So I'm going to draw a picture. Angle A is 38 degrees. That is less than 90. Okay? We know that's less than 90. All right? Because we should be able to recognize the number 38 is less than 90. So there's angle A. All right? And so it says to find an angle that's supplementary. Well, we could stretch out this side here and get that angle that we're looking for. If this is 38 degrees, then this angle plus 38 should equal 180. Now you could even set this up with algebra. Supplementary means that two angles add up to 180. Supplementary from the previous page of notes means that those two add up to 180. So I can set it up as an equation. The relationship supplementary is given to you already. We don't have to write the relationship. It's already there. So what we're going to do is we're going to subtract that 38 and get that x, that unknown angle measure, is 142 degrees. And we do need to classify that now, rereading the problem, as acute, obtuse, or right. Well, that angle is greater than 90 degrees, so that means it is obtuse. Okay? I want you to try and do number 2, which is very similar to what we just did, only the key difference is it's a complementary angle. I want you to pause the video and try and do number 2 on your own. If you're ready to check your answer, you can click play, and this is what we should get. Okay? We have angle A that's 43 degrees here, but if it is complementary to some angle, then it is formed together with this other angle to make a right angle, 90 degrees. So if this is my x, I know x plus 43 equals 90, because that's what complementary means. And so I just subtract my 43 from 90, and I get 47. And 47 degrees is an acute angle. So make sure we're reading the directions and giving everything that the problem is asking you to find. Okay, so let's keep moving right along with some other example problems. And in this case, I've actually given you some extra blanks to help you identify relationships here. Okay? So number 3, it says construct. Now, don't get confused by that word. All it means is draw. For geometry, construct just means to draw this as straight and neat as you can. And so let's take a look. It says construct vertical angles, label them angle 1 and angle 2. So I'm just going to draw an X. I'm going to pick one angle out of those 4 created, name it angle 1. And the other angle I'm going to name angle 2. Okay, we know they are vertical angles. And so it says, what's the relationship between those angles? The relationship is that vertical angles, and I can abbreviate angles with my angle symbol and then an S, are congruent. That's my relationship. You could write it out with the word, or you could write out with the symbol. So remember, this means congruent. Congruent. Okay, so that's the answer to this first question. Vertical angles are congruent. That's the relationship between the angles. So if angle 1 is 84 degrees, find the measure of angle 2. Well, measure of angle 2 has to be the same as 84. So it's 84 degrees. Not too hard. Okay, number 4. Construct a linear pair. Well, remember, a linear pair are adjacent angles that kind of form this straight line. So I'm going to draw that as a straight line. I'm going to have one angle coming up here like that. All right, I'm going to name one of these angles angle 1. The other one is angle 2. Now, I put 1 as the smaller angle because later in the problem it says angle 1 is 48 degrees. So I want to make it look kind of like my problem. It does say first, what is the relationship between the angles? Well, we know they are to be a linear pair. And we need to say linear pair angles are, you can ignore the bell in the background. Linear pair angles are supplementary. And there's no symbol for supplementary, unfortunately, so we have to spell out the word. You could abbreviate it as SUPP, period. Okay? But what does that mean? That means that their measures add up to 180 degrees. So the long way of writing that equation is the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Well, I know the measure of angle 1 is 48. Okay, if I'm just going to call this my unknown x, I'm just going to pick something for it. To find this then, I do subtract 48 from both sides. And when you do 180 minus 48, the measure of angle 2 then is 132 degrees. Okay? This is where they start to get a little more complicated because now I'm not writing out the words. I'm not stating what relationship they are. You have to look at the picture and be able to identify what that relationship is. And we're still going to identify a property here and find the value of x. All right? In these problems, we're going to identify the property and find the value of x. Yeah, just making sure that I didn't carry anything over to the other side. All right? So what I want us to do first is look at the relationship of the angles. We've got this angle here that is 66 degrees, and the angle right next to it here is 2x plus 2 degrees. And so we need to identify the relationship. Now, they are right next to each other. They do share a side. However, we have more specific information. Let me lock that for us so it doesn't twist on me again. We have a more specific piece of information. These two angles form a right angle. So they are complementary angles. Okay? They're complementary angles. And that means their measures add up to 90 degrees. So to do this problem, I'm going to write an equation using that. 66 plus 2x plus 2 must equal 90 because they're complementary angles. Okay, so then we can group these together. 66 plus 2, those are like terms. I don't know why I put the degree symbol with the 66. We don't need that for our equation. 66 plus 2 is 68, making my equation 2x plus 68 equals 90. Then we can subtract 68 from both sides, leaving 2x equals 22. And then we divide both sides by 2. We get x is equal to 11. And if it doesn't say what you're supposed to do in the problem other than just giving you the equation, you know that you just have to find x. But pay attention to what the problems tell you to do. Sometimes they tell you to find a specific value. So if I needed to find the value of this angle measure, I would plug that 11 back in for x. 2 times 11 is 22, plus 2 is 24, and 24 plus 66 does equal 180. So that's what we could do if we needed to plug back in. Let's try number 6. When we look at these two angles, they are next to each other. They are adjacent angles, but that's not the most specific information we have. We have this nice straight line here, and so these adjacent angles that help us form a nice straight line tell me that they are supplementary. When I have supplementary angles that add up to 180 that are also adjacent, the relationship is that they are a linear, LIN period is the abbreviation of the word linear, pair, PR period. Linear pair angles are supplementary. We can abbreviate. Now I can go ahead and set up an equation based on that. Supplementary means that they add up to 180 degrees. So one angle, 10x minus 10, plus the other angle has to equal 180. And now I go about solving my equation. Combine your like terms. Subtract 60. Divide by 10. And this time that's your answer. Again, you could plug back in and find the other angle measure, but we don't have to. All right, as we move along to some more examples in this lesson, we've got some more problems. We're going to do number 7 now, and we're going to look at this and identify the relationship first. Well, these two angles are formed by these intersecting lines, and they're opposite from each other or across from each other. All they have in common is that vertex. So these are vertical angles. And vertical angles are always congruent. Congruent. Let me rewrite that because that doesn't look very good. Okay? Congruent, meaning they are equal to each other. So my equation now is just one of them equals the other. And then we solve for x. Add 9 to both sides. Divide by that 4 then, and x equals 11. Now I could plug back in, but I should get 35 for both if I set them equal to each other. Okay, number 8 is very similar to one we've already done. These are complementary angles. Okay, meaning they add up to, I just about set it up wrong, didn't I? They add up to 90. They aren't equal to each other. They add up to 90. Okay, that's your relationship, or your property. All right, then we could solve that. I'll kind of go through that quickly. Okay, 3 plus 24 is 27. Subtract 27 from both sides. 7x equals 63. Divide by 7 then, and x equals 9. Okay? So what I want you to do to finish out this video, I want you to try and do these two problems on your own. I want you to try 9 and 10 on your own, set up the property, which is really just the relationship which is naming the angle pair and explaining, are they supplementary, are they congruent, or complementary? Okay? So do they add up to 180? Are they equal to each other? Or do they add up to 90, depending on the relationship? I want you to identify that relationship, set up an equation, and find these answers. Okay, we should get these answers for 9 and 10. If you need more time, pause. Okay. On number 9, these are a linear pair of angles. Linear pair angles are supplementary, so our equation is one angle plus the other equals 180, and you solve and you get x equals 18. Number 10, these are vertical angles. They are formed by these intersecting lines. They are across from each other. All they have is this vertex in common. So we set them equal to each other. Vertical angles are congruent. One angle equals the other, and we solve and we get x equals 17.